Hello students, we are here with your section B practical of physics. The aim of this practical is to draw the IV characteristic curve for a PN junction diode in forward bias and reverse bias condition. For this, the materials required would be a PN junction diode apparatus, connecting wires and pieces of sandpaper. Here the circuit diagram has been presented before you. So you are supposed to draw the circuit diagram in order to be very comfortable with the connections that you are going to do while you are using the PN junction diode apparatus. And I will explain you simultaneously in the video when you are supposed to connect which of the terminals to which of the terminals. Before we explain the video, I would like to just explain you about the least count of voltmeter or milliammeter or whatever device we are using in the physics laboratory. It has got something to do with the least count as well. Now, what is meant by least count? Least count is nothing but the smallest division it can measure or the smallest value that a device can measure. So when we are talking about the voltmeter, obviously we are just dealing with the voltage readings. Now in the picture that has been presented on the screen right now, you can see the first division is 0 and then the next bigger division is 0.5. And we have got 10 small divisions in between them if we just leave the 0 mark and count after that from 1 and right up to we go to 0.5. So this will total include 10 divisions. So now by applying the formula of least count, that is highest value minus lowest value divided by total number of divisions in between them, we can just find out the least count value. So if I just hold here that least value or the lowest value is 0 and the highest value is 0.5, if I am taking the two adjacent marks or points, then the highest value minus lowest value divided by number of divisions will become equal to 0.5 minus 0 divided by 10, and hence it would come up as 0.05 volts. So this is how you are going to place the least count of the voltmeter above the observation table that will be provided to you. Similarly, here is a milliammeter that has been presented before you, and again you are going to find out the least count by applying the same method that I explained you just now. So that is, here we can see the lowest value is 0 and the next higher value is 2, and there are 10 divisions, or if you can just see that there are, as per if there are 10 divisions you are going to divide it by 10, if there are 20 divisions you are going to divide it by 20. So according to the apparatus that has been provided to you, you are supposed to find out the least count before you start connecting the terminals and finding out the observation table. So the theory that is being actually based for this practical, or that is being followed for this practical, is nothing but that is a PN junction diode is formed when P-type semiconductor is fused to an N-type semiconductor and then creating a potential barrier voltage across the diode junction. And when we connect the P terminal of the diode to the positive terminal of the battery, and similarly the negative that is the negative terminal of the battery is connected to the N terminal of the diode. So this type of biasing is known as forward bias. Whereas the reverse bias is just the opposite, that is the P diode or the P terminal of the diode is connected to negative terminal of the battery and N terminal of the diode is connected to the positive terminal of the battery. and hence this will give you the biasing that is known as reverse bias. So this is all about the theory of PN junction diode. These two things only you are supposed to put up in your copies while you are recording the experiment, and everything has been explained clearly. Now we will move on to the explanation of how the things have to be performed when you are performing this IV characteristic curve. So as you can see, we have got a PN junction diode characteristic apparatus. That is, in the same apparatus you have got forward bias characteristic part and reverse bias characteristic part tracing. Now as you can see, this is a microammeter. Now this is milliammeter, and same way we have got voltmeter on both the sides. So this apparatus has got right hand side as the forward bias section, and it has got left hand side as the reverse bias section. So as I have already told you about how to find out the least count of the voltmeter, milliammeter, microammeter and so on. So your first task would be to find out the least count of voltmeter. Then you will be finding out the least count of milliammeter. In the same way, the formula that we have applied in the previous section of this video, that you have to apply the formula highest value minus lowest value divided by number of divisions. And since it is given in milliammeter, so it will be having unit as milliamperes. Whatever current you will be noting down, it will be coming in milliamperes. So these red colored terminals that you can see, they are actually your positive terminal, and the black colored terminals, they are marked, actually they are to be taken as negative terminal. At the same time, just you can now see there is a reverse bias section to the left hand side. Again it has got its own voltmeter, but this time it has got not milliammeter but microammeter. So same way you are going to find out the least count of this voltmeter and microammeter, that is for the reverse bias section. So just count on the number of divisions between the highest value and the lowest value and apply the formula and find out the least count. So that is, now what we are going to do is we are going to connect the terminals. That is, first of all, you can see the forward VF positive terminal is connected to milliammeters positive, and then milliammeters negative terminal is connected to P junction. Then N junction is connected to VF, that is forward bias negative terminal, and then forward bias the positive terminal is connected to voltmeter positive, and subsequently the voltmeter negative part is connected to the voltmeter negative part, that is written as V. So V stands for voltmeter, VF stands for forward bias voltage VF. So this is how you have to go through the connections. So, and just again I'll explain it, that is you have to connect VF positive to milliammeter positive, then milliammeter negative, that will be connected to P terminal or T junction. Then similarly N junction will be connected to VF negative. Then VF, that is VF positive, will now be connected to your, it will be going to, that is V positive, and VF negative will be going to V negative. This is how you have to connect the terminals. Now you have to just rotate this knob and you will have to see that whether milliammeter and voltmeter pointers are initially at 0. Then when you slowly rotate the voltage, you will see the readings that will be given out, and then you will have to just note down the readings. Similarly, this is for reverse bias condition that you have to go through, that VR positive will be connected to microammeter positive terminal, then microammeter negative terminal will be connected to N junction, then P junction will be connected to VR negative, and then VR negative will be connected to voltmeter negative, and similarly your this one, that is V positive, that is the positive terminal of the voltmeter, will be connected to VR negative, VR positive. So this is how you have to connect the terminals as per the circuit diagram that has been given. Now again you just switch on the apparatus, then rotate the knob and just note down the readings in the voltmeter and microammeter. So this is how you have to just note down the readings. Now you can see we have presented the observation table before you. So the first observation table case would be for forward bias characteristic. So you'll have to make a table consisting of 3 columns. The first column will be dedicated to serial number, obviously. Second column will be having the heading voltmeter reading, that is marked as V over here. And the third column will be marked as milliammeter reading, that is in milliamperes. Now see, you can see that is, it has been, the first reading has been written like 1 into 0.025. So what is the meaning of this 0.025? 0.025 is actually the least count of the voltmeter that was present in the PN junction diode apparatus. Now 1 means when the pointer was on the first division after 0, or of after 0, whatever is the first division, when the pointer was made to point at that in the voltmeter, then the corresponding reading in the milliammeter was 0. So it has been written as 0 into 0.2, where again 0.2 is the least count of the milliammeter. So likewise what you have to do, now when you just put the pointer towards the second pointer or the second division after 0, then you will be just writing it as, you will be multiplying it with the least count and putting up the value. But here I would like to suggest you that no need of multiplying with the least count, just put on the number of divisions. That is, what I mean to say is, you have to just put the number of division in the voltmeter reading column, and similarly you have to put the number of division in the milliammeter reading column. So no need of multiplying with least count, because if we are multiplying the each and every division with the least count, that will mean that we are scaling it with the same factor. So just there will be a shifting in the graph upside or downside. So that doesn't matter at all whether you are multiplying with it with the least count or not. So just put like 0, 1, 2, 3, 4, 5, 6, that is the number of divisions in voltmeter reading. And then you can see that in milliammeter reading, that is the few readings initially will be coming as 0, because you know that until and unless the cut-in voltage has been come across, you won't be getting any current through the PN junction diode. So that is, the few readings will be dedicated to 0 in the milliammeter reading, and then after that you will be getting a current, and then you'll have to note down each and every subsequent reading, and that is approximately up to 15 to 20 observations are required for this, so that you can get a smooth graph for this forward bias. Now the next one is for reverse bias. Again you'll have to make the same pattern of the table, or same table pattern would be there, but now here only the difference would be the microammeter reading, because in reverse bias condition the current flows in the microamperes range. So again you will be noting down here, as you can see the number of divisions has been written down, and then you can just complete your observation table. So you have been provided with 4 sets of observation table. According to your roll number, you have to just select that set and you have to just put down that observation value only. So that is mandatory for you all. Now here we would be just calculating the resistance of reverse bias and resistance in the condition of forward bias. So you will have to plot the graph, and then you will be getting this kind of graph you will be getting. Then you will have to take the slope in the forward bias and reverse bias condition, and you will be getting the resistance in case of forward bias and reverse bias. And I hope you know how to calculate the slope. If you have got any doubt, you can just ask whenever you have got your respective periods for physics. So that is how the graph will be looking like for your forward and reverse bias condition. Then you will have to mark the cut-in voltage or the barrier voltage. In the similar manner, in the reverse bias condition, you will have to mark the breakdown voltage. and then after that you'll have to put the result, that is junction resistance for forward bias is this much ohms and junction resistance for reverse bias is this much ohms, whatever you have calculated in the calculation part. And then finally the final heading would be precautions. You have to select 3 to 4 precautions and then you can just put down all these things in your copy. So I would like to again mention that what is the sequence that you are going to follow. On the ruled side, that is on the right hand side, obviously in your practical copies, that is ruled 1. You have to first of all at the top put the experiment number. Then the first line would be dedicated to aim, then materials required, then theory, then your procedure would be there. Then after procedure you will have to put the result and then precautions. This is all about, I'm talking about the ruled side. Now you'll have the plain side on the left hand side. So the first blank page, that is where you have written the aim. In immediate front of that there is a blank page. There you will have to put the diagram, circuit diagram. The second blank page, when you flip over the page, the second blank page will be dedicated to your observation table, and then the next page you can accommodate your graph, and at the same time calculation has to be there on the blank page itself. So just remember the sequence, and still if you have got any doubt you can reach out to us during your online class sessions and we are there for you to clear all the doubts. I hope this video works well and you get the notion of how to perform the experiment, that was to draw the IV characteristic curve for a PN junction diode in forward and reverse bias condition. Till then, take care of yourself. Thank you.